So this is up. Again, this is again up. So these are diaxial. And therefore, when the ring flipping happens, so the second one is correct. When the ring flipping happens, then two methyls will be equatorial. The question is, determine, what was the question? Approximately how much steric strain does the 1,3 diaxial interaction between the two methyl groups introduce into the diaxial conformation of this? Yani, in other words, as if we need to make a calculation or so. Anyway, in all cases, you can remember that first of all, which conformation is more stable? It's conformation number 1 or 2? Which one? Which one?
2.
2, of course. Why? Because here the two methyls are in the equatorial position. But why 2 is more stable? Because of this diaxial interaction. So we have a methyl, hydrogen, and then we have a methyl interaction. Do you follow me? Now, if that's actually, we need to check how much the energy, if that's energy, we need to know for each interaction how much. But anyway, what are the 1,3 diaxial? We have methyl, we have methyl hydrogen, we have hydrogen methyl. So we have 1,3 diaxial interaction. Got the point? Do you follow me, guys? This is actually what we mean by the question. The diaxial conformation of this is approximately because of this question. So the diaxial cis 1,3 is approximately 23 kilojoule. Right. As you can see from the previous question, if you check 4.47, it gives you how much energy it will cost if you have 1,3 diaxial interaction. Every 1,3 diaxial interaction, as they said. So every 1,3 diaxial interaction costs approximately 23. So we have in here 3 1,3 diaxial interactions. Therefore, the total energy will be higher or less stable by 3 times 23, which is 69 kilojoule per mole. Got it, guys? Got it?
Can you repeat, please?
Yeah, in previous example, because as I said, we cannot memorize numbers. We need to know for each 1,3 diaxial interaction how much energy it will cost. Do you follow me? So it's given, this data, it's given in the previous question, which is 4.47. If you check in the book. Do you follow me? Right? Read it in the question. It's written that the diaxial conformation of cis 1,3 dimethyl cyclohexane is approximately 23. This is less stable than the diequatorial. Drop us some chair. Okay, approximately how much steric strain does the 1,3 interaction between the two methyl groups introduce into the diaxial? Okay. So this different aspect here. Okay, the data given actually is different. It's giving you that the difference in energy between conformation number 1 and conformation number 2 is 23 kilojoule. Do you follow me? So they ask about the diaxial CH3 with CH3. Approximately how much it will cost. What do you think? How many 1,3 diaxial relationships we have in this conformation? In conformation number 1. How many? Say it. Speak up. How many 1,3 diaxial conformation, diaxial interactions we have? No, why 1? We have 3. We have 3. We have this group, and this group, and this group, right? So what does that mean? This will repel this, isn't it? So we have methyl, 1,3 diaxial interaction, isn't it? What else? We have methyl with this hydrogen. So we have methyl, hydrogen. We have this methyl with this hydrogen. So again, we have methyl, hydrogen. Do you follow me? Logically, the total of the 3 is equal or cost 23 kilojoule from the previous example. from the previous question, because actually the questions by order. So in the previous example, they give us that information that the difference in energy, we said structure number 2 is less stable, is more stable than structure number 1, which means the difference in energy, this is conformation 2, this is conformation number 1, the difference in here is 23 kilojoule. Of course, most likely this difference in energy, it's all about this 1,3 diaxial interactions. So the total, we have 3 1,3 diaxial interactions, right? Now the question is, approximately how much every 1,3 diaxial interaction will cost energy if the total is 23?
The first one is 11.
Mm-hmm. Okay.
The second one and third one is 6.
Why? Why? That's why you think this is correct. Why?
Because first
What
one.
we write
I'm sorry? The one who answered.
they mentioned that in the slide.
No, but why you think it's just, no, don't forget, yani, always, never, ever remember numbers. You will never be asked for numbers. It's all about logic. That's all. That's it. In this case, what do I want to say? Actually, any number is fine. I mean, you can give like this. For example, I assume that this is 10, and if everyone is, for example, 615, 615. That's true. I may assume that this is maybe 12, and every one of these, or maybe this is 13, and everyone is 5, 5. That's also true. The most important thing, that the sum of the 3 must be equals to the difference between the two conformation, this one. Secondly, it's very obvious that you must know that methyl-methyl interaction or repulsion, logically, definitely, must cost more energy compared to methyl hydrogen, where we had smaller repulsion. طبعا, again, in order to make the story short, which repulsion forces will be higher, methyl hydrogen or methyl-methyl, and why? Of course, as the size of the atom or the group increases, the repulsion forces increases. Get the point? So I don't really know the logic of this problem, but by all means, never ever remember numbers. It's all about logic, it's all about understanding. How many products are possible from the bromination of 1,4-dimethyl cyclohexane? A question from type. How many products possible for the bromination of 1,4-dimethyl cyclohexane? Actually, this question, we may answer it in different ways as we proceed in the chapters. But anyway, I'll just focus now on the formation, what we have studied so far. So the question is 1,4-dimethyl cyclohexane. So we have methyl, and we want to make bromination, and presence, of course, of HMU. Of course, assuming that, let's assume this. Of course, the question, the question you should, I don't know if this is the question as such, but anyway, in order for this question to be more precise, it must specify if it means monobromination or dibromination or all possibilities. Do you follow me? Anyway, let's assume we have monobromination. In other words, this reaction will produce, or we are focusing on the possibility of getting products where we have only one bromine atom will substitute a hydrogen. So we have different options. First, hydrogen, the bromine can go this side. Can come or can occupy this position. Can occupy this position. Can occupy this position. Now, can occupy this position. Now, if the bromine occupy this position, it will be the same like this position. Do you follow me? In other words, one of the possibilities that we have a methyl here and a bromine there, or we may have a bromine, methyl, and a bromine, and this is a methyl. But we have to take care of the possibilities even for the methyl, because actually we don't want to waste a lot of time for possibilities with no meaning. Anyway, if the methyl, the stereochemistry of the methyl should be given in order to also avoid, the ambiguity actually in this answer. طيب, is this the whole question, or there is also more details in this question? طيب.
Yes, Doctor, it's written like that.
Just as such. Anyway, in this case here, you have to take care of the possibility of stereochemistry here. For example, this methyl to be up, this methyl to be below, this methyl to be up the plane. Or, for example, this bromine to be, or the two methyls to be, because it's all about possibilities. Now you just have to check all possibilities and see. Now the other possibility, for example, the methyl here to be the same thing here. Two methyls are in the same stereochemistry, the same geometry, and this methyl to be above. Do you follow me? Still, we have also more possibilities that the two methyls here to be, for example, opposite to the, so we have a methyl here, and then the bromine above the plane, and then we have a methyl here is below. Do you follow me? And then still more and more. I don't know where this is. Maybe type this is actually in an exam which includes stereochemistry. And in other words, the chapter 5 which we started today, it was included in that exam, and therefore the student can simply figure out what's the meaning of all of this. Do you follow me? So the logic of this question is all about stereochemistry. So what are the possible aspects? Because this compound is different than this, different than that, different than that, and so on and so forth. Do you follow me? So
دكتور هو سؤال اختياري يعني معناته.
I know, but I mean this question in that exam, it has been included chapter 5, which we started today, which is not included in our exam. Do you follow me?
Yes, Doctor.
So because actually, as I said, here you need to specify the absolute configuration, you need to specify what's the S, what's the R, and so on, in order to distinguish one from the other, to see if this is the same like that, the same like this, and so on and so forth. Anyway, ignore this question. Just focus on the material which is already included in the first exam. Our first exam will include only the material from 1, 2, 3, and 6, and 5 is not included. Isn't it? 1, 2, 3, 4, 1, 2, 3, 4, and 6. 5 is not included. Okay? According to the chapter 9. Any other question? Now, the exam, regarding the exam will be two parts actually. There will be a multiple choice question, and there will be 30 questions, and there will be essay questions. So it will be like two halves. Approximately the 30 questions, you have almost like 50 minutes to go, and then almost like 40 minutes for the essay questions. So this actually, and now regarding the multiple choice questions or all the questions, you can always go backward and forward to use your time efficiently and not to make you under a lot of stress. Do you follow me? So the questions will be designed like that. Everything will be on Moodle. So there will not be something to be like take home exam or whatsoever. Everything, all the exam will be on Moodle. Essay questions actually, Maria, I didn't decide yet, but it will be a few questions about some explanation, some other aspects of the exam. No, actually, we can't do this because it will be too much regarding the exam, actually, because some questions include structures and so on. So in order for clarification, every question will be, or maybe a few questions will be in the same page. That would maybe be fine. Yes, you can move between the questions. Yes.
Doctor, I have another question.
Sure. Go ahead.
Page 47.
Page 47.
Yeah, in chapter 2.
Okay. In edition 9. In edition 9.
Yes.
All right. Yes, but just let me first answer a question of Omar. Is there any drawing in the essay questions? Yes, there is actually. And in this case, whenever you are required to draw anything, what you need to do, just draw it on a piece of paper, make a photocopy by your phone, and then send it to your email and include it in the question. Do you follow me?
Doctor, but this will take time.
I will take this into consideration. Therefore, I will minimize that in the essay question, most likely to be fill in the gap. You follow me? If something required you to draw, then it will be minimized in order to be taken care of. In all cases, Omar and everyone else, always remember any exam is, relatively speaking, issue. It's not about the time is part of the examination. So it will be just for all of you the same conditions. Anyway, your question again, sorry, Taif? Taif was asking. 47?
Yes.
47? Okay. 47. Okay, this one. 47. Yes, which question, please?
Problem 240.
Problem 240. 47, are you sure about the number? About the page number?
Edition.
About the page number. The page number.
47.
47 here. 47, I have it 47. But it's just work example. Is this what you are asking about?
No.
Is it in the problem?
سؤال.
Is it in the problem? In the end chapter problem?
Yeah.
Then it's not 47. Are you sure you're talking about edition 9?
أيوة قدام الصفحة.
طب أنا والله كمان قدام الصفحة. أنا عندي هاي 47 as I said, unless we are talking about different edition. أنا عارف. Anyway, which
قصدي الصفحة 74 أو رقم السؤال.
74 ولا 47 ولا 74 قصدك؟
47.
47.
74
أيوة في section 2.9.
You are talking about the same question?
لا حول.
You are confusing me, guys. I am here, I have the edition which I have. In 47, I have, yeah, let me check. Unless we are talking about different edition, I don't know. This is actually with the edition which I have it online. So 47, it's just, Can you tell that question very quickly in order just to use the time more efficiently?
Doctor,
Yes.
the page you're opening is correct. After the work example, there's a problem. 214. Page 47, there's a work example and then problem.
There is 214. Yeah, this is what I was asking. So, okay. So will either of the following reaction take place to a significant extent as writing according to the data in table 2.3? Okay, well, that's great. Okay, so but you need of course to go back to the data in the table. Please, while I am drawing the two questions, go back to the table in order to give me the pKa of the compounds. Okay, so we have HCN. Now the question is, will this reaction take place or not? In order, as I said, these are acid-base reactions. In order to decide, we need to have the information about the pKa, right? So we have HCN plus CH3CO2O minus Na plus goes to Cn minus plus CH3 or NaCN, let's say. NaCN plus CH3 CH2OH. Now what's the pKa of ethanol and what's the pKa of HCN? Is this
Ethanol 16,
16 is ethanol and the pKa of HCN?
9.31.
Okay, 9.31. Now what do you think, very quickly, will this reaction take place or not? What we said about acid-base reaction to take place, always going from low pKa into high pKa. See, from low to high, then for sure it will go, and it will go significantly, because actually you may calculate what we call it the K equilibrium. If you remember general chemistry, I don't know if you took already general chemistry 2101 or not yet. Did you take general chemistry 2102, guys?
Yes.
Okay, do you remember then K equilibrium, how we simply calculate it? You can just write it like Ka of Ka, let's say product, over Ka reactant.
Of reactants.
Right, and in this case, if you convert this into Ka right away, what you're going to get, you are going to get, reactant over product, I'm sorry. So the Ka is Ka of reactant over product. In this case here, the Ka here will be 10 to the power minus 9.31 over 10 to the power minus 16 point, how much? Just 16 or?
16.00.
Okay, 16, okay, 0. Right. In this case, what you are going to get, 10 to the power of approximately 16 minus 9, which is almost like 5 point something. Let's say 5, approximately. We're talking about approximately. You can do it at home if you wish, in a way or another, precisely. And just make the log pKa in order to get the pKa, the Ka of each. In this case, as you can see, whenever we have the K equilibrium to be very much high, like 5 decimal places, in this case, this is a very likely to happen or to take place. Or the reaction will go in this direction in very high extent. Do you follow me? That's actually the logic of the question. You get the point? Is that clear, guys? Okay. So as I said, you can even guess not just if the reaction will take place or not. You can even guess to much extent actually of the reaction can take place. Any other question? What's this? 342. Wrong equation. CH3CO2. Shayma, is this question? Shayma, what's your question? Yet I didn't get your question, Shayma. Which question you are talking about? 3, 4?
Dr. Smith, you wrote the equation about correct, wrong.
Which equation?
CH3CO2. It's not CH3CH2.
Okay. CO2 minus, you mean?
Yes.
Yeah, it doesn't matter, but the idea is the most important thing. Let me just go back to the example exactly. So it's 47, right? CO2, oh, I'm sorry, okay, it's fine. So this is here CO2 minus and A plus, and therefore here we're gonna get CH3, CO2H. All right? Okay. Any other question? Is there any other question?
دكتور بس استفسار
Yes, sir.
لما ناقشت سؤال 24 في chapter 3.
Mhm.
ليش أول شيء يعني حليت unsaturation degree؟
دائما هو in general speaking in order to deal with the structure from the formula, always as organic chemists, always refer to the degree of unsaturation in order to have an idea what you are talking about. What if you have more degree of unsaturation than what's given? معاي? Okay, let me just give you a question to show you what's the importance of the degree of unsaturation. For example, give me a structure which fulfills this, which is also dialkene. Here, dialkene, remember. See, for example, C5H6. I want dialkene. That's it. If I specify like this. Now, when you calculate the degree of unsaturation of this, what you are going to get, let's make it 8, C5H8. In this case, what you are going to get, the degree of unsaturation will be 3. Which means, if you want to include the dialkene, that means you have 1 degree of unsaturation, you need to take it into consideration. If you have 1 degree of unsaturation, which is not alkene, it must be what then? What it must be? If what degree of unsaturation? If a degree of unsaturation is not alkene, it must be what? Or what's the possibility of any unsaturation? Every unsaturation could be what? Either a double bond or what?
Triple bond.
Two unsaturation will be a triple bond. I'm talking about a cycle or a double bond. Do you follow me? In this case, now very quickly here, in this case, I can draw it like this here. This is a structure which fulfills this condition. I'm pretty sure you didn't get my point. Did you get my point or you didn't get my point? The importance...
I didn't.
I said I'm pretty sure because I was talking very fast. Anyway, again, now I'm asking here. Suppose, imagine this is the question. You follow me? This is the question. You have a molecular formula of C5H8. Write down a structure which includes or which contains dialkene. In other words, 2 double bonds, isn't it? Right? Do you follow me?
Yes.
Right. Now, here, the easiest way always to have a comprehensive idea about what we have, what we are dealing with. First of all, from the molecular formula, in order to get some knowledge, we need always to calculate the degree of unsaturation. Let's calculate it and see slowly to see what's the importance of this. Once you calculate the degree of unsaturation, you will find the degree of unsaturation is equal to 3, isn't it? First, is that true or not?
Yes.
Right. So what does that mean? You have, in this molecule, you want to draw a structure which has a 3 degree of unsaturation. 2 of them is alkene. Then the third, it must be a cycle system, otherwise you will be lost. You don't know what to draw then. Do you follow me?
Yes.
That's why actually the easiest way, let's say I have 5 carbons, I have a cyclic 2 double bonds, just to draw the 5 carbons as a cycle, insert 2 double bonds, or I can draw simply a 4 double bond like that, a 4 cycle membered ring, and then the 5th carbon to be outside. Or simply I may draw it like this way, for example. Something like that. Any one of these will be fine. Do you follow me? You get the reason why I didn't include the degree of unsaturation in this case? Alright, that's actually, this is always true because the degree of unsaturation is extremely important piece of information for us as chemists because it will give us some idea about the inside of the molecule, what we have inside the molecule. And you may remember my words when you study applied spectroscopy. Whenever you study applied spectroscopy, this piece of information is extremely important for us as organic chemists. Shayma and Khalaf, there are Khalaf asking question 224. Page 59B. What's the meaning of curved arrows? Yes, is this you, Khalaf?
No, I am not.
Okay, Omar, go ahead, Omar.
Victor, can you upload this record today?
Inshallah, I will work on it after a few hours, and then inshallah in the night you will have it.
Okay, thanks.
Khalaf, what's your question? 225 is mistake. What's the meaning of mistake? 225. Khalaf, write down very quickly in order to use the time more efficiently. What's your question? Is your question about 225? Yeah, 59B. I am in there. Which question? What's the meant by curved arrows? Use curved arrows to draw the protonated form of each Lewis space. I think we have done this question before, or similar question. Simply in this case, Khalaf and everyone else, this is question 225, page 59B. Now use curved arrows. In this case here, for example, this is the Lewis structure of this compound. Now, it's actually the Lewis structure of this compound is not fully written. You must know that at the oxygen, there are two lone pairs in here. So, when this reacts with H+, because we need to write with protonated H+, when this reacts as H+, the oxygen in here, it will behave as Lewis space. It will donate its lone pair to the hydrogen, and therefore this will be written like this. The hydrogen will make a covalent bond with the hydrogen, and therefore it will carry a plus. That's actually what meant by curved arrow. Actually, it is written, even we have studied this and discussed this in the tutorial. This is what we mean by curved arrow, Khalaf. Sure. Now, Shayma, you have a question, Shayma? Shayma, can you please repeat your question? Question 2C. Which page, Shayma? Which page you are talking about? Which question, Shayma? First fall 2017. Just fall 2017. Test fall 2017. Question C, the hybridization. Question 2, C, the hybridization. Question 2. All right, hybridization. Okay, so you are talking about C. Where is the C? C, yeah, sure. C is here. Okay. So 3 is SP. Atom 4 and 5. 4 and 5. Okay. All right. Okay. Anyway, Shayma and everyone else, please. Sulfur here. Whenever we have sulfur like this, you must know, because sulfur is actually in the group number 6, which means it has another 2 lone pairs actually in there. Oxygen, the same thing here. Whenever we write it, even if we draw it like that, you must know that there are 2 lone pairs in here. So what's the hybridization of any atom like this? According to the table and what we have studied or what we have discussed in the beginning of this lecture and in general chemistry, The sulfur and the oxygen here, in this case, they are surrounded by 4 electronic groups. And therefore, the hybridization is sp3. Do you follow me? So this is again sp3. Always. Do you follow me? Got it, Shema? The hybridization is sp3. Yes, yes, the question is always yes. Yeah. For example, what's the hybridization of all atoms in here? What's the hybridization of the chlorine, Shema, in this compound? What's the hybridization of the chlorine atom in this compound? The chlorine atom, chlor. Exactly, خلاص. Since it is attached or connected to 4 electronic groups, right away it's sp3. If it is connected to 3, it is sp2. If it's connected to 2, it is sp. That's it. These are the whole possibilities what we have. It's either sp, sp2, or sp3. That's all what we have. Do you follow me? I think it's enough, guys, because we are almost like 2 hours. It's enough for today, and inshallah I'll see you next Wednesday. But I will send you maybe more information on WhatsApp if there is any clarification about the exam. All right? Hayakumullah, and I wish you a very nice evening. Inshallah, tonight I will upload both lectures, the lecture of now and the lecture in the early morning. All right? Have a very nice day. Thank you. Bye-bye.